Hi, let's now get started with Module 4, Ancillary Services, and its first block, Why Ancillary Services. Before to get to discuss the why and eventually the how, we first need to discuss what those ancillary services are. As you must have understood from the introduction, this relates to this idea of reserving these services for eventually using them to keep the power system into balance. Actually, ancillary services are more than that. They are all the services required by the transmission and distribution system operators, and that would enable them to maintain integrity and stability of their system, so transmission and distribution, as well as power quality. If you want to know more about these ancillary services, their definition, and how they are considered throughout Europe, for instance, Eurelectric has released a number of documents discussing them, also discussing what will be the future of these ancillary services as we see it today. These documents are available through the slides associated to this lecture, where these links are actually hyperlinks that will lead you to the documents as PDF. There are various types of ancillary services, and we generally classify them as related to frequency control, voltage control, and system restart. In this lecture, we'll mainly focus on frequency-related services, as they are those that are used to keep the system into balance. You can see that there are lots of small boxes here, because actually in practice, there are very different ways to define services for frequency control. Indeed, you should be aware of naming convention and terminology for ancillary services. In different areas, different countries with different system operator, we may use different terms to actually refer to the same ancillary service in practice. Also, the boundaries between ancillary services might be different. So what we call a certain type of ancillary service in a certain area with a certain system operator may actually overlap different type of services in another area with another system operator. Let's exemplify that. If we were to look in a very high-level manner at the USA and Europe and different type of frequency control ancillary services, we may actually describe what those are and classify them from fast to slow. So fast to slow is actually a way to look at how easy it is to activate them and how fast you get the full response from these providers of ancillary services. In the USA, roughly, we would talk about regulation, spinning reserve, non-spinning reserve, and replacement reserve. If we're going to Europe, also from a high-level point of view, we would talk about primary, secondary, and tertiary reserve. So you see, there's not even the same number of blocks here for the USA and Europe, so the number of types of ancillary services for frequency control. And if we were to make some connection, you would realize that what we talk about when we say regulation type of ancillary services in the USA, this could fit partly in primary and secondary reserve, and this would be the case also for some other of the services in the US and how we would connect them to Europe. Actually, Denmark is an interesting country in that sense, since Denmark is originally split in two in terms of power system, with a foot on the northern power system, Nordel, and a foot on the continental Europe power system, UCTE. We actually add two types of operational practice and ancillary services that are still represented today if you look at the Danish power system and the electricity market. There's also operational practice that has to be considered, since when you have all these ancillary services that are available, you may think in different ways in terms of how you want to consider them and activate them eventually. Roughly, there are two main approaches. You may use a reactive or corrective approach, or you may use a proactive or preventive approach. In the first approach, this reactive or corrective approach, what is happening is that when you observe an imbalance or deficiency, you could say, in terms of frequency, you will first use your fast ancillary services to try to restore frequency, and then you would move on in your sequence of available ancillary services if you don't manage to restore very rapidly frequency. So you go first with primary, then with secondary, then with tertiary, that can also be called manual reserves. You go into this order. If you were to apply a proactive or preventive approach, then you would do it the other way around. As when you decide to use your ancillary services, this could be a bit in advance. You may actually predict you're going to have imbalances in terms of energy that are going to have an impact on frequency. And you could say, since I have predicted it, I could use my slower reserve in the first place, which are most likely easier to operate and cheaper. So you would use this one first, and then you would use secondary and primary to compensate for deviations that are still left. So your order of consideration would be from the slower type of reserve or ancillary services to the faster types. But why would the power system be off balance in the first place? I'm sure you have a fairly good idea by now. In principle, you may have something happening on the demand side, or on the supply side, or on the system side. If we think of the demand side, the electric load, the demand in the dead electricity market, it was scheduled and the market was cleared based on some forecasts. Eventually, this forecast may have some errors, and what is happening in terms of practical electricity consumption could be different from what was scheduled and foreseen in the first place. The same goes on the supply side with renewable energy generation. The scheduling and the clearing of the dead market was based on some forecasts, also on some idea of what we could be producing with wind farms, solar power plants, etc. But as we get to real time, the forecasts may have been wrong, and then there's a discrepancy between what was predicted and scheduled eventually through the dead market and what is happening in practice. For conventional generators, there might also be differences, and this might be due to outages, some operational difficulties, some maintenance, or some other reasons. On the system side, there might also be outages of the transmission equipment or some other assets in the transmission and distribution system, and there could also be some congestion, for instance, between different areas of the power system or different market areas. Let's look at a few practical examples so as to illustrate what's going to happen. We are zooming now on a specific day, the 1st of April 2014, and I got this data from Nord Pool and Energinet, the system operator in Denmark. In this plot, on the x-axis, we have the time of the day for this 1st of April 2014, and these 24 hours of the day correspond to the 24 market time units after clearing the dead market. So based on the clearing of the dead market and the forecast available on those websites, we have here in plain or bold forecast of electricity consumption for DK1 and DK2, which are the two sides of Denmark, DK1 being Western Denmark, DK2 being Eastern Denmark. On the y-axis, we have power, which may also be looked at in terms of energy, since eventually when we integrate power over this market time unit of 1 hour, we get the energy block that is to be consumed. Let's compare this dash, so realized, and plain, so forecasted, electricity consumption. For the two sides of Denmark, it looks pretty good. These forecasts of electricity consumption seem to match in terms of amplitude, in terms of trend, etc. Still, there is a slight mismatch at the beginning of the day here, and also this mismatch amplifies for Western Denmark as we go in the afternoon and the evening. For the eastern part of Denmark, the match is fairly good. When we talk about ancillary services, eventually imbalances and the activation of these ancillary services, what we care about is the difference between what was predicted and scheduled through the day at market and what is really happening. So if we make this abstraction, we obtain these two curves here. We still have the hours of the day on the x-axis, but then on the y-axis, we look at power surplus or deficit, which we again can reinterpret in terms of energy surplus and deficit. For decay 2, in red here, plain, we were saying, based on the previous plot, that there was a fairly good match. And when we make this abstraction, we realize that we are always close to zero, maybe with a little spike here at the end of the morning, but overall, the balance is fairly good on the consumption side. Looking at Western Denmark, decay 1, these imbalances are accumulating over the day, so there's a fairly large mismatch, it seems, up to 100 megawatt hour to be handled, especially in the afternoon. So this will require, you expect, the use of ancillary services and eventually the use of the balancing market for that purpose. Looking at the other side, so it's wind power generation, since in Denmark we have quite a lot of wind power generation. Same day, same origin of data, and we're going to look at what was predicted and eventually scheduled through the day-ahead electricity market and what actually happened. The axes are the same. On the x-axis, time of the day or market time units after clearing of the Nord Pool, L-spot market, and on this y-axis, power, which you may also reinterpret in terms of energy as integrating this power production over the market time unit of 1 hour and then giving you energy blocks that are scheduled after clearing of the day-ahead market or that are eventually supplied. The plain curves are for the forecast, in blue for decay 1, in red for decay 2, and the dash curves are what actually happened. Here visually, there's quite more difference between the forecast or the schedule on the wind power generation side and what really happened. Though you have to remember the scale. When we looked at electricity consumption for whole region or for whole country, the scale was actually quite larger. So even though we had small differences between the schedule and what really happened, or the forecast and what really happened, we had to scale to the size of the whole country. Here, the scale is not as high. We are talking of up to 1 gigawatt hour, which is like 4 times less than the type of scale we were looking at before. So this kind of differences may actually not represent so much energy, though there's still to be quite a good match between forecast and what really happened in decay 2, so on Eastern Denmark, while on Western Denmark, the mismatch is fairly high, especially in the afternoon. If we were, again, to think of it in terms of imbalances, we have to subtract what really happened with what was scheduled, and this is what we obtain. As we just said, the mismatch is actually very limited for the first half of the day on both sides of Denmark, and then as we enter the afternoon, the mismatch is still limited on the eastern side of Denmark, but then the mismatch is fairly high on the western side of Denmark. So all in all, if we consider the demand side and the generation side, what do we do? Do we consider that this was a high imbalance or not? Do you think that the system operator needed to reserve a lot of ancillary services for this kind of situation or not? It's actually difficult to say. In practice, if you want to quantify the need for ancillary services, you also have to do that fairly in advance. It's going to be maybe a day in advance, maybe more, or maybe less. It depends on the market areas and the system operators. But still overall, if you want to quantify the need for ancillary services, how does that relate to the actual operation? It actually relates to the uncertainty you have at the time you have to make decisions. Let me explain. A day in advance, or a fair amount of time in advance, you want to know how much of these ancillary services you need to book. Why? you want to book them because if there are imbalances, they will be used. These imbalances, you don't know about them at the time of the booking. So they relate to the uncertainties you have in your power system. The uncertainties, we say, they're in the electric demand. There are forecasts of electric demand, and these forecasts most likely are going to be partly wrong. There's going to be a part of error. There are uncertainties in renewable energy generation, again, due to the forecast and potential errors. There are other uncertainties related to these other assets or conventional generators, and then we may see that in terms of reliability, there is still a slight chance that an asset is going to fail or is not going to be able to deliver. We have to combine all these uncertainties and look at an overall uncertainty, and then the system operator can quantify reserve. And somehow the idea of reserve is to be able to react for a wide range of potential outcomes that cover this overall uncertainty assessment. In practice, it's actually a bit more complicated than that, since yes, we need to account for uncertainties, but there might also be some other operational practice aspects or constraints that could be ramping, that can be commitment, that we also need to consider at the time of reserve quantification. If you want to find some more information about the actual balance in a power system in various market areas, ancillary service provision, different type of activation, etc., we are actually lucky enough that all this data seem to be more and more available online on the websites of market operator and also of system operators. For example, in Scandinavia, you can get historical data at the Energinet webpage, and this is an hyperlink that you may want to visit that's available through the slides that are associated to the video lecture. And you can also have real-time data through the Nord Pool page under this title of regulating volumes. And as I said, you may also actually find a lot of other data that can be useful for market studies, for forecasting, etc. Some other examples, if you're interested in other countries, other areas of Europe here, but it could be for the US, you have some real-time and historical data for France that's available on the RTE webpage, RTE being the system operator for France. You have historical data available for the Netherlands on Tenet webpage, Tenet being the system operator for Holland. And then you also have a very nice app for Spain that was set up by REE, which is the system operator for the Spanish area. Thanks for listening. I would like to invite you to use the self-assessment quiz to check your understanding.